Suppose you have a sample from a geometric distribution. Show that y bar is sufficient for p. First of all, to avoid a fence post error, let's note that for this problem, the probability that yi equals little yi is p times 1 minus p to the yi minus 1. That means the probability of success on trial I. Some books define it with a shift of 1, so it's important to keep that straight. Now, if that's the probability for yi, then the probability for all of the y's, since they are independent, is the product of them all. So we have n factors of p, and we've got 1 minus p to the y1 minus 1, y2 minus 1, etc. up to yn minus 1, which we can rewrite as p to the n, 1 minus p to the sum of yi minus n. Now, the factorization theorem, to check if this is sufficient, the factor with the parameter can have no yi's except in the form of the statistic. Now, if we look at this, the only yi's that show up are in the form here of sum of yi. There, now it's written specifically in terms of y bar. The important thing here is that there are no y's at all other than that. So if we factor out the part with the p's, which is all of it, we would have a second factor of 1. The requirement is that only y bar show up in the part with p, and that is satisfied. So y bar is a sufficient statistic by the factorization theorem. Now you might wonder, why can't I just always multiply by 1 and say that? Because in some problems you might have extra y's that are not part of the statistic, and in that case it's not sufficient. So there's a proof for the geometric distribution.